Hi class! Today we'll be talking about human impact on the ecosystem, starting off with some of the negative effects and finishing up with some of the positive effects that humans have on the environment. First, we'll start with overpopulation, which gets more and more publicity as our population grows, especially when we hit milestones like a new billion. Here is a bit of our history. You can see for most of the graph here, most of our history, we grew really slowly. Right? That's because while we had high birth rates, we also had high death rates. A lot of kids dying before they reached the age of 5, which kept the population from growing too fast. However, starting around here, our population began rocketing upwards with great advancements in medicine and agriculture. Our population experienced a huge explosion, and we are now around 7.6 billion people on Earth. You can see that this graph goes a bit into the future, 2025, estimating over 8 billion. And we're seeing some changes in the population growth. We have to ask ourselves about what are the effects of overpopulation. One of the biggest ones is it puts a huge strain on resources. More people means we need more food, more water, more housing, more products, more goods need to be available. There are some studies that show overpopulation reduces the economy. While we need more things, the effects of extra people sometimes outweigh the benefits of producing those goods. And of course, more people means more pollution, especially depending on the organization of the people in huge cities or suburbs, etc. However, the dangers of overpopulation are likely overblown, partially because of this thing called the demographic transition. So if you look at this graph, you can see it lists 5 stages. Sometimes it's shown as only 4. But either way, our population started out stage 1. The whole world for most of our history was in this stage where, again, high birth rates but high death rates, so our population didn't increase much. However, then with improvements in agriculture and medicine, sanitation, etc., our death rate fell dramatically, especially infant mortality. So people kept on having a lot of babies, but those babies stopped dying so much. They started making it to maturity. So this caused our population to increase rapidly. However, as we went into stage 3, we kept improving on death rate. That kept going down. However, when people realize that their babies are going to make it to maturity, they tend to stop having as many. And there are other effects that reduce birth rate. Increased education for women, more opportunities for women also caused a decrease in birth rate. And this means the population growth slows down. As countries move into stage 4 or 5, the birth rate decreases even further, at which time you may get the population leveling out or even decreasing. So a lot of countries have seen this already happen, and we think most countries as they develop will go through this transition as well, which means we think that population will increase, will slow down, and eventually level out. So we may never see the doomsday scenarios of continents crowded out with people. Our next effect we're going to look at is invasive species. Here's a picture of a Burmese python, which is unfortunately now common in parts of Florida where it has invaded. Invasive species, what they are species that are just not native to their ecosystem and that can cause harm. The reason they can do this is when they're introduced to a new ecosystem, some species can outcompete the native organisms. They may not have any predators, they may not be affected by the same diseases, they may just be really suited to the new environment. So for example, those Burmese pythons in Florida Everglades, they've been able to outcompete alligators and other predators for food, and the environment is just really suited to them. So since they have spread so dramatically, we're now seeing some negative effects. Here's a bunch of invasive species on the east coast. Canada geese, of course, came from the north. Stink bugs are a more recent newcomer from Asia. Kudzu covers a lot of the southeastern U.S., which we introduced it purposefully to control erosion, but now it has spread dramatically. And many of these species came accidentally, we brought them, or on purpose. But invasive species can also get to a new ecosystem on their own, but often it is through human intervention. All right, our next effect is climate change, which is obviously a very big effect that humans are having on the environment. Before we go into climate change itself, you need to understand a little bit about the greenhouse effect. So greenhouses obviously are very warm, and we use them to grow plants. And what the greenhouse effect is comparing a greenhouse to Earth's atmosphere. So what happens when solar radiation comes to Earth is it goes through our atmosphere and then it gets trapped. So the incoming sunlight is allowed to pass through, but then the heat that bounces off the planet is often reflected back down to the surface, keeping the planet warmer than it otherwise would be. If you look at this image, you can see this happening, right? Sun's light comes through the atmosphere and some of it warms the planet. Some of it comes in, bounces off the planet, and escapes. However, some of it bounces off the planet, comes back to the atmosphere, and the atmosphere reflects it back down. Right? So the atmosphere traps this heat, keeping Earth warmer than normal. Now the greenhouse effect isn't necessarily bad. It's good that it keeps Earth warmer. It also keeps our temperature more stable, along with the oceans trapping heat. The problem is, with climate change, we are making the greenhouse effect stronger than it normally would be. So the way this works, to simplify it, is that we're releasing more carbon dioxide, usually from burning fossil fuels. This makes the atmosphere thicker. A thicker atmosphere traps more heat, and this causes the worldwide temperature to increase. So as I mentioned, it's primarily caused by the burning of fossil fuels, coal, petroleum, natural gas. Oftentimes people will say, well, CO2 levels go up and down all the time, and that's true. They do go up and down through natural cycles, but we are making a bigger difference than we have ever seen in Earth's history. And so this is part of the cause of polar ice caps melting, and we'll get to some of its other effects. One thing to mention about the atmosphere, while our atmosphere may seem huge and like we can't affect it, it is actually really small compared to the size of the planet. If you compare the size of Earth to an apple, the atmosphere is basically the thickness of the peel. So you're not talking about a huge thick layer of gas. It's relatively thin, and we know we can have effects on it. I'll show you a few quick graphs here. This one graphs time on the x-axis, and then it's got carbon dioxide in ppm, which is parts per million. So you can see since 1800, basically when the Industrial Revolution began kicking into high gear, the amount of CO2 in the atmosphere has dramatically increased since we began burning fossil fuels on a large scale. Another graph here shows the concentration of CO2 in the atmosphere, that is this line, and anthropogenic emissions, which is how much we release, that is the blue line. And you can see as the blue line increased, then the orange line began to increase as well. Now here is a graph showing the natural cycle hundreds of thousands of years before today. So here's 400,000 years in the past. And you can see CO2 does go down, up, down, up, down, up throughout history. However, you can see that here, okay, this is about 375. Now we are above 400 parts per million. We are way above anywhere the natural cycle has ever been. And we are concerned because when CO2 goes up, you can also see a resulting increase in temperature. These lines seem to mirror each other, and so we are very worried that as CO2 climbs to never before seen levels, we will see temperature follow a similar path. One more graph. This shows the global temperature anomaly, meaning how much higher we are than normal. or lower. So 0 means like average. So you can see in 1900 we were below average. It was a period of cooling, but since we have dramatically climbed until we are up here quite a bit above what the average temperature normally is. So one of the effects of global warming is glacier retreat. Here you can see Shepherd Glacier, a picture from 1913 on the left, and a picture from 2005 on the right. Glacier retreat is basically when glaciers begin melting faster than they can be replaced through snowfall. And this is a concern because a lot of the Earth's population gets its fresh water from glaciers. So we have a strong interest in keeping them around. Another big effect of global warming is ocean acidification, the oceans becoming more acidic. Okay? The reason that's happening, more CO2 in the atmosphere. The atmospheric CO2 can go into the ocean, which through a few processes can cause the pH of the ocean to drop. So the ocean is getting slightly more acidic, and this is very damaging to organisms with shells like coral and shellfish. So it can lead to a process called coral bleaching, shown here, where the coral basically dies off, leaving just the shells of the previous coral. Here's a poster about coral bleaching, so you can look through that for more info. But basically, healthy coral has algae living inside it, but when the coral gets stressed, the algae may leave, and this can cause the coral to die and leave just the bleached shell remaining. Alright, before we close, I want to touch on a few of the beneficial human impacts because we do positive things for the environment as well. Some of them include establishing wildlife preserves, protecting areas of the planet, in other words. We also protect endangered species, try to keep species from going extinct. By using renewable resources, we reduce the impact of our energy use on the planet. And through recycling and reducing our energy use, we also can mitigate some of the damaging effects of our products and technology. Here is just a worldwide map of protected areas. So the green is on land and the blue is in the ocean or the coast. So you can see, actually, we have quite a bit of the planet is protected, meaning there are specific rules that apply about hunting or using that land. And this allows a lot of species to flourish without human effects. So this has been a presentation on human impact. Feel free to rewatch if you missed anything, and I hope you got something out of it.